looking at factorising quadratics, and we're looking at a situation where we have our coefficient of the x squared term, in other words our a, to be not equal to 1. So an example I'm pulling from our methods book, exercise 3b, and we'll look at question 8c as our first one. So 8c is we want to factorise 5x squared plus 23x plus 12. So it's quite a big set of numbers, and we need to look at how do we factorise this. Now, a couple of ways of doing it, but the way I like to do it is to split up the middle term. So the first thing we do is we need to set up a little table, and then we have to remember that we're looking for factors of a times c. So we're looking for factors of 5 multiplied by 12, which is obviously 60. So we're looking for the factors of 60. So first things first, let's list down some of those. So the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 12s. Yeah, 5 12s, good. 6 10s, 7 no, 8 no, 9 no, and then we're back to 10. So they're all the factors of 60. And we're looking for the factors of AC that add to give B. So we're looking for two factors that add to give 23. Well, if we look down our list, then quite obviously the factors that we are interested in are those two. Okay, 3 and 20 are 23. Now all the terms are positive, so we're going to have two positive factors that we're interested in. So our next step is to split the middle term. So it doesn't matter whether you do plus 3x, I'm going to do it this way, and then plus 20x plus 12, pardon me. So it doesn't matter if you do the 20x and then the 3 or the 3x and then the 20. It makes absolutely no difference whatsoever. So first of all, let's just quickly recap. Where did those numbers come from? Well, 3x plus 20x, all right, 3x plus 20x is 23x. And notice the other two terms have not changed. So that's all I've done. And where did the 3 and the 20 come from? Well, they've come from the factors of 60, 5 times 12, that add to give 23. All right. So next step is we're going to factorize the left-hand side, the left-hand two terms, and then the right-hand two terms. So we're looking at 5x squared plus 3x. Well, there's only one factor. Common factor of those two terms is x. 5x plus 3. Okay, and then we look at the 20x and 12 and we factorize that. So what goes into both 20x and 12? Well, let's try 4. Okay, and we end up with 4 times what is 20x? Well, that's 5x. And 4 times what is 12? Well, that's 3. And we end up with that. Now notice they're the same. Okay, and that's what you want. You need those two to be the same. And so we're left with a common factor of 5x plus 3 in both terms. So we take that to the front, and then we leave what's left, x plus 4. Okay, and that's it factorized. Now, just to confirm, if I come over here and I start with the 5x plus 3 and the x plus 4, and I expand it, that's going to be 5x lots of x plus 4 plus 3 lots of x plus 4. And if I multiply that out, 5x times x is 5x squared, 5x times 4 is 20x, 3 times x is 3x, 3 times 4 is 12. And you can see 20 plus 3, 23x, that I'm back to where I started. Okay, so that's an example of factorising. There are a few more in question 8, but that'll do for the moment. They're all done exactly the same way. I'll just very quickly start you on another one. For example, you might want to look at h. So if I look at 8h, for example, 8h says 5x squared minus 4x minus 12. Okay, so again, you set up your table. It's a times c that adds to give b. Well, a times c is 5 times, so it's 5 times negative 12. Okay, and that's negative 60 again. Interesting. And then I've got negative 4 this time. Okay, so I've got to add factors of negative 60 that add to give 4. Well, coincidentally, I've already got my factors. Okay, so what I'm looking for now, they're all up at just a bit above. So what are the factors that are separated by 4 units? Well, in this particular case, I just changed my highlighter color. Okay, it's these two, 6 and 10. There's 4 difference. So I need those two terms to multiply to give negative 60. So it's either going to be negative 6 and positive 10, or positive 6 and negative 10. And which one of those, when I add them, will give negative 4? Well, it's quite obviously that one. Okay, and so I'm going to go 5x squared plus 6x minus 10x minus 12. So I've split up the middle term into the two factors that I identified. Left the first and the last terms as they are. Common factors. I wasn't going to do all this one, but I am now, obviously. X outside of 5x plus 6. And I've got minus 10x and minus 12. So I've got a negative 2 as our common factor, leaving with positive 5x and positive 6. Once again, you'll notice that I've got the same inside the brackets, which is my common factor of that line, and end up with that. Okay. So that's some examples of factorising. You can have a go at some more in question number 8. Question number 9. Which one will I do here? Let's have a look at question A. Okay, so looking at question number 9, and we'll do A because it's not too bad. So we've got 3y squared minus 12y minus 36. Now you can do this exactly the same way. Not a problem at all. And you can still factorise it and you'll get your answer in the end. What I want you to start to pick up and realise is that sometimes there might be shortcuts. What do you notice about the numbers 3, 12 and 36? Well, they all have a common factor of 3. I can take out a common factor of 3 and that will leave me with y squared minus 4y minus 12. And now it's a little bit easier to factorise. So notice I've now got a coefficient of 1. So now I can factorise that. So what two numbers, so again I can set up my, it's still A, C and B. What are the two numbers? Well, A is 1, C is negative 12, so it's going to be two numbers that multiply to give negative 12, 1 times negative 12, that add to give negative 4. So my factors are 2 and 6, 1 and 12, and 3 and 4. I need them to be separated by 4 units. Whoops. So that's obviously going to be those two. It's got to be negative 4, which means the bigger of the two numbers is going to be my negative. So therefore, my factors are x plus 2, x minus 6. So that's an example of if you can see that a factor has a common factor in the coefficients, then you can take that out and do it. And then the last one is 10b, is the request. So we'll have a look at 10b. 10b says, oh, factorise. Okay, so this is probably a bit more complicated, so we'll finish with this one. 2 lots of x minus 1 all squared plus 5 lots of x minus 1 minus 3. Wow, there's a couple of little interesting characters to do there. So there's a couple of ways you can do this, but what you could probably do is expand the brackets first. If I was trying to find the roots, I'd actually do it a different way, but I'm not doing that. So let's just expand the brackets first. Oh, you know what? I'm going to do it this way. So here's what I'm going to do. I'm going to say, well, can you see that we've got something squared plus something to the power of 1 minus 3. So what if I just say, why don't we let a different variable, let's call it u, equal x minus 1. So what will that equation become? Well, it'll become 2 lots of u squared, because I'm just replacing x minus 1 with a u, plus 5u minus 3. Now let's factorise that. What are the factors of 2 times 3? So again, we're going to go 2 times 3 that had to give b. So we've got 2 times negative 3, which is negative 6. That had to give 5. Well, it's going to be 1 and 6. We want it to be positive 5, so it's going to be negative 1 and positive 6. So let's do that. Minus u plus 6u minus 3. Just double checking. Is minus u plus 6u 5u? Yes, it is. Is negative 1 times positive 6 negative 6? Yes, it is. So we're going to take out a common factor of 2. Oh, I can't take out 2 here. What am I doing? Just take it. Whoa, what happened there? Sorry, welcome back. So I'm going to take out a common factor of u, leaving me with 2u minus 1, plus a common factor of 3, 2u minus 1. And that's going to equal to u plus, 2u minus 1, u plus 3. Now you'll notice that my original equation is in terms of x, not u. So I'm going to replace now, this is where it gets a little tricky, I'm going to replace the u with what it's equal to. Okay, so I'm just going to write this out and then I'll let you have a look. Okay, so you'll notice what I've got here. Okay, so there's the u, and there's what I've replaced u with, remembering up here. Okay, there's the u, that's what I've replaced it with. Because I need my answer in terms of x's. Now I'm just going to expand the brackets. The inside brackets, I should say, not the outside ones. So it's going to be 2x, so 2 times x, and 2 times negative 1, which is negative 2, minus 1. This one is going to be x minus 1 plus 3. So if I tidy that up, that's going to be 2x minus 3. Apologies, I bumped the record button, so hopefully it didn't delete anything. So I'll just finish this off. So minus 1 plus 3 is positive 2. And so there's my solution. Now that is quite a challenging question. You'll notice in the textbook it's actually labelled as a CF. And CF is a complex familiar. So that's quite a challenging problem to finish off with. So we've gone through a different lot of questions. That was some examples from exercise 3B.